Nature is a world of matter. Matter in nature exists in a high diversity of forms. However, these forms can be categorized into only three states, namely solid, liquids, and gas. A solid has a fixed shape and volume. The shape of a liquid, on the other hand, is not fixed. It changes according to the shape of the container holding it. A balloon changes its shape and volume easily under pressure from external forces. This is because the gas within it doesn't have a fixed shape and volume. You can see many ice cubes in this beaker. Each ice cube has a fixed volume. At room temperature, the ice cubes melt bit by bit until they all change to a liquid form. Liquid water changes to gaseous steam when heated to boiling point. When steam is cooled, it condenses and changes to water. This shows that matter exists in the three states: solid, liquid, or gas at different temperatures. Melting point is the temperature at which matter changes from a solid to a liquid. Boiling point is the temperature at which a liquid changes into a gas. There are many large rocks in a quarry. Large rocks are blown into smaller pieces or stones by explosives. These stones are ground into grains by machines and eventually into powder. If we observe the powder under a microscope, we can see that matter is made up of very fine particles. A smoke cell is a device used to show that particles exist in a gas. Spray smoke into a smoke cell and cover it with a cover slip. Then observe the content under the microscope. Under the microscope we can see tiny light sparks moving irregularly. The tiny light sparks are in fact smoke particles reflecting the light. This is similar to the moon, which, though only reflecting sunlight, looks as if it is shining itself. In the smoke cell experiment, the irregular movement of tiny light sparks is the result of the smoke particles being bombarded by the surrounding air particles moving around them. Let's do another experiment. If we mix 100 milliliters of alcohol with 100 milliliters of water, we'll find that the final volume is less than 200 milliliters. Why is this? Let's use black beans to represent alcohol particles and sago particles to represent water particles. Black beans are larger than sago particles, just as alcohol particles are larger than water particles. When sago particles are mixed with black beans, the total volume of sago particles and black beans becomes smaller. The reason is that as black beans are larger than sago particles, the spaces between the black beans can accommodate many sago particles. Something similar happens when we mix water with alcohol. The smaller water particles fill the spaces between the large alcohol particles. This again shows that matter is made up of particles and that there is space between the particles. In a solid, particles are closely packed together, each having its fixed position. Solid particles cannot move easily and can only vibrate in their fixed positions. Therefore, solids usually have fixed shapes and volumes. In a liquid, the separations between particles are similar to those in a solid, but the particles can move freely. The shape of a liquid can change according to the shape of the container holding it, but a liquid cannot be compressed easily. Particles in a gas are far away from one another. Gas particles move quickly and irregularly most of the time. Therefore, a gas doesn't have a fixed shape and volume. A cube of sugar is made up of many particles. After sugar has dissolved in water, the matter seems to have disappeared, but the water tastes sweet. When sugar dissolves in water, sugar particles diffuse and mix with water particles. The sugar particles remain in the water, though they are not visible. Perfume and other highly volatile substances give off a powerful odor which can be smelled easily. This is a result of the quick diffusion of particles in air. Use a dropper to add a tiny drop of colored liquid carefully into a glass container of water. Watch carefully and you will see colored liquid diffusing gradually until it is evenly diffused in the water. This is the result of the unceasing movement of the liquid particles. Compared with liquids and gases, the diffusion of particles in solids is much slower. This test tube is filled with agar. Put a blue copper sulfate crystal into the test tube. And a few days later, part of the agar becomes blue, and the blue copper sulfate crystal becomes smaller. This shows that the particles of the copper sulfate crystal diffuse into the agar and that the diffusion is not affected by gravity. In the 19th century, the British botanist Robert Brown examined some pollen grains under the microscope. He noted that the pollen grains moved unceasingly in water. This phenomenon is called Brownian movement. Water itself is made up of particles. Water particles move around irregularly. Pollen grains in the water are bombarded by water particles on all sides. As the pollen grains are bombarded by different numbers of water particles from different directions, they move along in a zigzag path. This is similar to what we see in the smoke cell. Hong Kong is under the influence of high pressure affecting southern China. It will be sunny today and in the days to come. The temperature will rise to 24 degrees Celsius. Atmospheric pressure is something we experience in our daily lives. Consider what happens to the box when we drink a boxed drink. When we suck the drink up with a straw, the box starts to collapse. The reason is that air pressure presses on the paper box from all sides and crushes it. The Earth is covered with a layer of air 100 kilometers thick. The incessant movement of air particles results in atmospheric pressure. Shake a bottle of soft drinks vigorously. Open the bottle and the soft drink ejects from it. The reason is that when the soft drink is shaken, the dissolved carbon dioxide in the soft drink is released to exert a pressure on the inside of the bottle. When the bottle is open, the gas will eject together with the soft drink. In fact, all gases can create pressure. A gas is made up of particles. But gas particles have more space around them than liquid or solid particles. They can move freely and much more quickly. Gas particles colliding unceasingly with a surface results in the creation of air pressure. At every moment, many particles collide with the surface of the container and pressure is formed. The steel beads in the plastic cylindrical container represent gas particles. When connected to the mains, the piston at the bottom of the kinetic model kit moves up and down quickly. The piston causes the steel beads in the container to jump unceasingly, in a way similar to the gas particles. The steel beads collide with the surface of the container, resulting in the creation of pressure. A pressure gauge is a device used to measure air pressure. A Bourdon gauge is used to measure the air pressure in different containers. Connect a syringe to a Bourdon gauge. Compress the air in the syringe. The pointer on the Bourdon gauge shows the air pressure inside the syringe. There is a coiled hollow metal tube in the Bourdon gauge. When the Bourdon gauge is connected to the syringe, the gas in the syringe moves into the metal tube, which is straightened as a result. The metal tube will be stretched in proportion to the level of pressure of the gas. The metal tube is connected to a pointer. When the metal tube moves, the pointer rotates correspondingly. The rotation of the pointer shows the pressure of the gas. There are various applications of air pressure in everyday life. For example, without air pressure, tires will go flat easily and will wear out very often. This wall-mounted clock is hung on a pressure sucker firmly fixed onto the wall by atmospheric pressure. A glass of rainbow cocktail is made up of 5 different kinds of drinks. The different color drinks arrange themselves in 5 layers because they are of different densities. Different kinds of matter have different densities. Matter is made up of particles. Particles have different masses and are separated from one another at different distances. Consider 2 objects of the same volume. The one with closely packed particles of a greater mass is said to be an object of high density. The object with particles of a smaller mass, widely separated, is said to be an object of low density. Divide the mass of an object by its volume and you will get the mass per unit volume, or density of the object. When different liquids are mixed, the liquid with a lower density floats on top, while that with a higher density sinks to the bottom. Water and oil are liquids of different densities. Water is denser than oil. If water is poured into oil, the water will sink below the oil. A piece of wood can float in water because the density of wood is lower than that of the water. Place a piece of iron into water and it will sink to the bottom. This is because the density of iron is higher than that of water. But if the piece of iron is placed in liquid mercury, it floats. This is because the density of iron is lower than that of mercury. Balloons used by the observatory to collect meteorological data have a density of only 0.09 kilograms per cubic meter, which is much lower than the density of the air surrounding the balloons. Therefore, the balloons rise in the air. A hot air balloon rises because objects with a lower density rise upwards. In a hot air balloon, the density of air falls as it is heated. The surrounding air at lower temperature has a relatively higher density. A mass of hot air of lower density is lighter than a mass of air of the same volume but higher density. Lighter objects rise to the top, therefore a hot air balloon rises. A thermometer shows temperature by expansion and contraction. When the temperature rises, the mercury in the bulb of the thermometer expands and the mercury thread rises. When the temperature falls, the mercury in the bulb contracts and the mercury thread falls. Therefore, the height of the mercury thread shows the temperature reading. The phenomenon of expansion and contraction can be explained by the particle model. Particles in matter move unceasingly. In a solid, particles can only vibrate. Liquid particles have higher energy content and can move around over a longer distance. Gas particles have even higher energy content and can move around over a much longer distance. If an object is heated, or when the temperature rises, the particles in it gain energy. The increase in energy content enables the particles to move over longer distances and the object expands. As particles in a solid have fixed positions, the expansion of a heated solid is not obvious. Liquid particles can move around freely over a short distance. When they are heated, the particles in liquid gain energy and move farther apart. Hence, a liquid expands more than a solid. Gas particles are far apart from one another. As the particles gain more kinetic energy upon heating, they move over a much greater distance. Hence, a gas shows the most remarkable expansion on heating. The surfaces of roads or bridges are divided into blocks and the gaps filled with an elastic material. This design is useful in preventing the road surface from rising or bending when the material expands or contracts. The longest bridges in Hong Kong are the Tsing Ma Bridge, the Ting Kau Bridge and the Gup Soi Mun Bridge. The length of these bridges may increase or decrease as a result of expansion and contraction. These changes must be taken into account in the design of the bridges. The Tsing Ma Bridge, for example, makes use of movement joints to allow for the expansion and contraction of the bridge. The deck is fixed at the Ma Wan abutment by steel pins to allow only vertical rotation of the deck. From there, expansion and contraction are catered for by sliding bearings at the side-span pier tops and at the main tower legs and by road and rail movement joints on Chingy Island. The road movement joints consist of a number of steel beams laid transversely across the deck, closely packed together and joined by a rubber coating. As the bridge moves, the joints slide along further longitudinal steel beams supporting them from below, the beam and rubber combination above stretching or contracting like an accordion. The movement joints on the rail are designed to accommodate the full range of deck movements to a limit of 1.1 meters in each direction. They might be the largest of their kind in the world.